Hello guys, my name is Prince and this is Math Center. Subscribe to my YouTube channel for more videos. Post your comments and questions on my social media handles and I'll respond to it. We are on the topic vectors. In the previous video, we solved a question on finding the bearing and magnitude of a column vector. In this video, we are going to solve another question on finding the bearing and magnitude of a column vector. Let's take the question for this video. Find the magnitude and bearing of vector mn, and the components of vector mn are 4, -2. So to find the magnitude of vector mn, we say that the magnitude of vector mn is equal to square root of the x component squared, so 4 squared, plus the y component squared, which is -2 squared. Remember that if a component is negative, you have to put that component in a bracket before squaring it. So -2 squared. For this one, 4 is positive. So you can choose to either put it in a bracket or not. But if it's negative, make sure that you put it in a bracket before squaring it. So the magnitude of vector mn is equal to square root of 4 squared plus -2 squared. And when you do this on your calculator, you are going to have 4.5 units. Remember, we are leaving our answer in one decimal place, so 4.5 units. Let's move on to the direction of mn. Direction of mn. When you want to find the direction of a column vector, the first thing you need to do is to draw the diagram for the vector. So you draw our x and y plane here. We are beginning from M. That is our starting point, and the ending point is N. Now, we are beginning from N. The x component is 4, positive 4. It means that we will move to the right, so 4 on the right. The y component is -2. It means that we will move downwards, so -2, so 2 downwards. As I said, you don't draw this thing to scale, so don't worry yourself with measuring it accurately. All you need to show is that you move away from M and you create a mark here and indicate it as 4. But make sure that 4 is longer than 2, because in natural sense 4 is longer than 2. So when you are drawing it, let's see it on the diagram that 4 is longer than 2. Okay, so you move 4 to the left and you move 2 downwards. So when you draw a line from 2 here and you draw a line from 4 here, they are going to meet at this place, and where they meet is N. So you join M to N. Now look at the direction of the arrow. It's moving from M to N. Okay, so what is the bearing, or what is the direction? We take the direction from the geographic north. This is the geographic north. So we take the direction from the geographic north to the vector. I hope that is clear. So this is the vector. The line is the vector. So we are taking the direction from this geographic north to the vector. But we know that from this point here to this point here is already 90 degrees. Okay. So all we need to find is this angle here. If we're able to find that angle and add it to 90 degrees, we will get the direction of the vector mn. Okay. So how do we find that angle? I'm going to call that angle what we are looking for. I'm going to call it theta. Now, if I call this angle here theta, you can see that I can draw a small right angle triangle for it. With this point here as M, we have this angle here. Now, you can see at this point, that is where the right angle will be formed. So the right angle is formed here. So I'll bring that right angle here, and this side here is N, as we have on the diagram. We know that moving from this M to this point is 4, so it means that this length here is 4. Moving from this side here to N is 2, so it means that this length here is 2, and we have theta here. Considering theta, 2 is opposite to theta and 4 is adjacent to theta. So we have opposite, we have adjacent. We can use tan to find the value of theta. So we can, from the diagram, you can say that the direction of vector mn is equal to 90 degrees plus theta. So let's find theta and add it to 90 degrees. tan theta is equal to opposite, which is 2, divided by adjacent, which is 4. So theta is equal to tan inverse of 1 over 2. If you find the tan inverse of 1 over 2 and you correct that to 1 decimal place, you are going to have 26.6 degrees. Okay, so we can say that the direction of MN is equal to 90 degrees plus theta, which is 26.6 degrees. And when you add this, you are going to have 116.6 degrees. So for vector MN, the magnitude is 4.5 units and the direction is 116.6 degrees. Thank you for watching this video. Don't forget to like and subscribe to this channel for more videos. Click on the subscribe button to subscribe. Share this link with others so that they can also enjoy the videos. In the next video, we are going to solve another question on finding the direction and magnitude of a column vector. Bye-bye.